Hi everyone! In this video, we're going to take a look at how to solve definite and indefinite integrals using U-substitution. So let's start with this problem. What is the integral of 1 over 2x plus 4 dx? So the idea behind U-substitution is to make your expression simpler. So we can simplify this into, let's say, 1 over u, right? So let u be equal to 2x plus 4. Okay, so we can turn the denominator into a u. And now the second step is to differentiate this with respect to x. So du over dx, we're just differentiating it. So the derivative of 2x plus 4 is going to be 2. So du will be equal to 2 times dx. And then dx will be equal to 1 over 2 du. Now we can substitute it back into this integral. We have the integral of 1 over u, and dx is 1 over 2 times du. And since 1 over 2 is a constant, we can move it outside of the integral. So we have this times 1 over u du. Now, the antiderivative of 1 over u is the ln of u. So the ln of absolute value of u plus c. The last step is to substitute u back into our expression. So we have 1 over 2 times ln of the absolute value of 2x plus 4, and then plus c. So that is your answer. How about the integral of x divided by x plus 1 dx? So the first way is to use u substitution and say let u is equal to x plus 1. But I also want to show you the second way, which is just divide it using long division. So x divided by x plus 1. So we have 1, and then 1 times x plus 1, right? And then you subtract, then you get minus 1. So this integral is equal to, the quotient is 1, then minus the remainder, which is 1 over x plus 1 dx. So this way is completely fine. And now we can split the integral apart. So we get 1 dx, 1 over x plus 1 dx. So let u equal to x plus 1. Then du over dx is equal to 1. So du is equal to dx. The antiderivative of 1 is simply x. And then the antiderivative of 1 over u is the ln of absolute value of u plus c. So we get x minus ln of x plus 1 plus c. And that's it. The integral of 1 over the square root of 3x minus 4 dx. So same thing as last time. Let u equal to 3x minus 4. So du over dx is 3. Then du is equal to 3 dx. And dx is equal to 1 over 3 times du. So we get the integral of 1 over the square root of u times 1 over 3 times du. And we get 1 over 3 times the integral of u to the power of negative 1 over 2 times du. Okay, so the antiderivative of this is what? It's going to be u to the power of positive 1 over 2 divided by 1 over 2 plus c. And we get 1 over 3 times 2 times the square root of u plus c. And finally, we have 2 over 3 times 3x minus 4 plus c. And that's it. The integral of e to the power of 5x dx. This one is really simple. We let u equal to 5 times x. So du over dx is equal to 5. Then du is 5 times dx. And dx is 1 over 5 times du. Dx is 1 over 5 times du. We bring the constant out. Then the antiderivative of e to the power of u is itself. And the last step is to put u back. So we get 1 over 5 times e to the power of 5x plus c. The integral of sine 2x dx. So let u equal to 2x, then du over dx is equal to 2, then du is equal to 2 times dx, and dx is 1 over 2 times du. So dx, again, is 1 over 2 times du. We bring the constant out, and we get 1 over 2 times the sine of u du. The antiderivative of sine is what? It's going to be negative cos u plus c. So how do I know it's negative cos? Well, I use this trick. So whenever I'm on the test, I just write down sine, cos, with 2 negative signs here. We're at sine, right? And then when we integrate, we go up. And so we end up over here. And we get negative cos. So if we go down, it's the derivative. So the derivative of sine is cos. The integral of cosine is going to be sine. We just go up. So it's a pretty neat trick. We get negative 1 over 2 times cos of 2x plus c. The integral of ln of x divided by x dx. So let u equal to the ln of x, and you will see why in a second. So du over dx, we differentiate it, and the derivative of ln of x is 1 over x. So we multiply it, and we get x du is equal to dx. We have u divided by x times dx, and then dx is x times du. So as you can see, these will cancel out, and you get the integral of u du, which is 1 over 2 times u to the power of 2 plus c, and that is simply 1 over 2 times the ln of x to the power of 2 plus c. The integral of 2x times the square root of x to the power of 2 plus 1 dx. So let's simplify whatever is inside the square root. Let u is equal to x squared plus 1. So du over dx is equal to 2x. And then du is 2x times dx. So dx is 1 over 2x du. And then dx here is 1 over 2x times du. So again, as you will see, these will cancel out. And you get u to the power of 1 over 2 u. And its antiderivative is 3 over 2 divided by 3 over 2 plus c. So this will be the same as multiplying it by 2 over 3. And we get 2 over 3 times x squared plus 1 to the power of 3 over 2 plus c. The integral from 0 to 1 of x to the power of 3 times x to the power of 4 plus 2 to the power of 4 dx. Now we're going to solve this definite integral using U-substitution. So the first step is to say that this is equal to f at 1 minus f at 0, according to the fundamental theorem of calculus. So what is f of x? Well, f of x is the indefinite integral x to the power of 3 times x to the power of 4 plus 2 to the power of 4 dx. So let u equal to x to the power of 4 plus 2. And same thing as last time, we're going to differentiate it. And that gives us 4x to the power of 3. Then du is 4x to the power of 3 dx. And finally, dx is 1 over 4x to the power of 3 u. So continuing on, f of x is x to the power of 3 times u to the power of 4. And dx is 1 over 4x to the power of 3 times du. And as you can see, the x to the power of 3's will cancel out. We have 1 over 4 times u to the power of 4 du, which is 1 over 4 times 1 over 5 u to the power of 5 plus c, which is basically 1 over 20 u to the power of 5 plus c. And that is 1 over 20 times x to the power of 4 plus 2 to the power of 5 plus c. And we're almost done. So we now have f of x. So what is f at 1? Well, that's going to be 1 over 20 times 1 to the power of 4 plus 2 to the power of 5. This is 243 over 20. Now how about f at 0? F at 0 is 1 over 20 times 0 to the power of 4 plus 2 to the power of 5, which is 32 over 20. So f at 1 is 243 over 20 minus 32 over 20. That gives us 211 over 20, which is 10.55. The integral from 0 to the square root of pi of x times cosine of x squared dx. So this is equal to f at the square root of pi minus f at 0. So f of x is the indefinite integral x cosine x squared dx. So let u equal to x squared, then differentiate it with respect to x. So du over dx is 2 times x, then du is 2x dx, then dx is 1 over 2x du. We get the integral of x times cosine of u, and dx is 1 over 2x times du. The x will cancel out, and we move the constant in front, so we get 1 over 2 times the cosine of u, and the antiderivative of that is sine of u plus c, and sine of u is basically sine of x squared plus c. Now that we have f of x, let's go ahead and find f at the square root of pi. That is 1 over 2 times sine times the square root of pi, and this is to the power of 2, which is 1 over 2 times sine of pi. So let's draw what sine looks like. So here is going to be 2 pi, here is going to be pi, and here is going to be 0. So sine of pi is going to be 0. And 0 times 1 over 2 is going to be 0. How about f at 0? Well, f at 0 is 1 over 2 times sine at 0 squared, which is 0. And finally, f at the square root of pi is 0 minus 0. And the final answer is 0. The integral of x plus 1 to the power of 1 over 3 times x plus 2 dx. This can also be solved with U-substitution. Since x plus 1 is inside this root, let's make that u. So u is x plus 1, du over dx is 1, then du is equal to dx. Now, we have the integral of u to the power of 1 over 3 times x plus 2. And what is x plus 2? Well, here's a trick. Since it's u is equal to x plus 1, then it must be that u plus 1 is equal to x plus 2. So that is basically the trick. So here we have u plus 1, and dx is du. What do we get? We get u to the power of 4 over 3 plus u to the power of 1 over 3 du. And the antiderivative of this is what? It's u to the power of 7 over 3 divided by 7 over 3. And that's basically the same as multiplying by 3 over 7 plus u to the power of 4 over 3 divided by 4 over 3, or the same thing as multiplying by 3 over 4 plus c. So we have 3 over 7 times x plus 1 to the power of 7 over 3 plus 3 over 4 times x plus 1 to the power of 4 over 3 plus c. The integral of 2 times x to the power of 2 times the square root of x plus 1 dx. So this can be solved with u substitution, with u being x plus 1. Then du over dx is 1, so du is equal to dx. Now let's move the 2 outside, and we have x squared times the square root of u, and dx is du. What is x to the power of 2? Since u is x plus 1, then u minus 1 is equal to x, and x squared is u minus 1 to the power of 2, which is u squared minus 2u plus 1. we have 2 times u squared minus 2u plus 1 times u to the power of 1 over 2 d. We have 2 times the integral of u to the power of what? Oh, it's 5 over 2 minus 2 times u to the power of 3 over 2 plus u to the power of 1 over 2 du. We have 2 times the antiderivative of u to the power of 5 over 2. And that is u to the power of 7 over 2 divided by 7 over 2, which is the same as multiplying by 2 over 7 minus 2 times the antiderivative of u to the power of 3 over 2. That is 5 over 2 divided by 5 over 2, same thing as multiplying by 2 over 5, plus u to the power of 3 over 2 divided by 3 over 2. And again, that's multiplying by 2 over 3 plus 3. 2 times 2 over 7 is 4 over 7 times u to the power of 7 over 2 minus 2 times 2 times 2 over 5, that's 8 over 5, u to the power of 5 over 2, plus 2 times 2 over 3, which is 4 over 3, u to the power of 3 over 2, plus c. And we're almost done. It's 4 over 7 times x plus 1 to the power of 7 over 2 minus 8 over 5 times x plus 1 to the power of 5 over 2 plus 4 over 3 times x plus 1 to the power of 3 over 2 plus c. The integral of x times the square root of x plus 3 dx. So let u equal to x plus 3, then du over dx is 1, so du is dx. Now let's substitute the u. So dx here is du, and what is x going to be? Since u is equal to x plus 3, then x is u minus 3. We have u minus 3 times u to the power of 1 over 2 du. This is the integral of u to the power of 3 over 2 minus 3 times u to the power of 1 over 2 du. And what is the antiderivative of this? Well, it's going to be u to the power of 5 over 2 divided by 5 over 2, which is the same as multiplying by 2 over 5. And here we have 3 times u to the power of 3 over 2 divided by 3 over 2, which is the same as multiplying by 2 over 3 plus c. So let's further simplify this into 2. And the last step is to put the u back. So we have 2 over 5 times x plus 3 to the power of 5 over 2 minus 2 times x plus 3 to the power of 3 over 2 plus c. The integral of the square root of e to the power of x minus 1 dx. So this right here can be solved with u substitution. So let u equal to e to the power of x minus 1. Then differentiating with respect to x, we have e to the power of x. So du is e to the power of x dx. And dx is 1 over e to the power of x du. So let's put it in here. We have the integral of the square root of u, and dx is 1 over e to the power of x du. So what is e to the power of x going to be? Well, in order to turn it into a u, you have to consider this equation here. And e to the power of x is u plus 1. We have the square root of u times 1 over u plus 1 du. So we have the square root of u over u plus 1 du. And here is our integral. So it turns out that we have to use u substitution again. And instead of using u, we're going to use the letter v this time. So what is v? We have 2 options. We can try this one, and if you do, you will see that it doesn't work because we cannot cancel out the numerator. So we can set v equal to the square root of u, which is u to the power of 1 over 2. So differentiating dv over du, we have 1 over 2 u to the power of negative 1 over 2. And what is that going to be? That is 1 over 2 times the square root of u. So we have 2 times the square root of u dv is equal to du. So here we see du, right? And du is 2 square root of u times dv. We bring the constant out, and we have this square root of u times this square root of u, which gives you u over u plus 1 dv. And now it's time to change the u into the v. And how exactly are we going to do that? Well, remember here we said v is the square root of u. So it must be that v squared is going to be u. We have 2 times v squared divided by v squared plus 1 dv. So how do we solve this integral? If you look at this, so v squared, it's v squared divided by v squared plus 1, right? So 1 times v squared plus 1, and then we're going to subtract, and what do we get? We're going to get minus 1. So the quotient is 1, we have 1, and the remainder is negative 1. So we have minus 1 over v squared plus 1 dv. We have 2 times the antiderivative of 1, which is just minus the integral of 1 over v squared plus 1 dv. If you remember your trigonometry derivatives, then you will recognize this integral. So the derivative of arctan is 1 over x squared plus 1. That means the integral of 1 over v squared plus 1 dv, that's going to be arctan of v. Let's go ahead and fix that. So this will be arctan of v plus c. We have 2v minus 2 arctan of v plus c. Since v is the square root of u, we can substitute it back. So the square root of u minus 2 arctan, the square root of u plus c. And again, u is e to the power of x minus 1, so don't forget that. We have 2 times e to the power of x minus 1 minus 2 arctan, and the square root of e to the power of x minus 1 plus c. The integral of the square root of x to the power of 4 divided by x to the power of 3 minus 1 dx. The first step is to simplify this expression. So if you remember, we have the square root of x over y, and this is the square root of x over the square root of y. So here we have the integral of the square root of x to the power of 4 divided by the square root of x to the power of 3 minus 1 dx. The square root of x to the power of 4 is x to the power of 2. Then we use u-substitution. So let u equal to x to the power of 3 minus 1. So du over dx is 3x to the power of 2. So du is 3x to the power of 2 dx. And dx is 1 over 3x to the power of 2 u. This gives us x to the power of 2 divided by the square root of u. And dx is 1 over 3x to the power of 2 u. The x squared will cancel out. We bring the constant out, we have 1 over 3 times the integral of u to the power of negative 1 over 2 u. The antiderivative of this is u to the power of positive 1 over 2 divided by positive 1 over 2, which is the same thing as multiplying it by 2 plus c. This is equal to 1 over 3 times 2, which is 2 over 3, then the square root of u. So the square root of u is the same thing as the square root of x to the power of 3 minus 1 plus c. The integral of x to the power of 5 times the square root of x squared plus 1 dx. So let u equal to x squared plus 1. Du over dx is 2 times x, then du is 2x dx, and dx is 1 over 2x times du. We have the integral of x to the power of 5 times the square root of u, and dx is 1 over 2x du. We bring the 2 out, we have 1 over 2 times, this is x to the power of 5, and we have an x here. So we have x to the power of 4 times the square root of u du. We want to turn the x to the power of 4 into a u somehow. Right? So if you look at this, we have u is equal to x squared plus 1. So x squared is u minus 1. And x to the power of 4 is u minus 1 to the power of 2. So u minus 1 to the power of 2 is what? It's u squared minus 2u plus 1 times u to the power of 1 over 2 du. This is equal to 1 over 2 times u to the power of 2 times u to the power of 1 over 2. This is u to the power of 4 over 2 times u to the power of 1 over 2. And we add the exponents together, which gives us u to the power of 5 over 2. Minus 2u times u to the power of 1 over 2. That is 2u to the power of 3 over 2 plus u to the power of 1 over 2. Let's find the antiderivatives. So the antiderivative of this is what? It's going to be u to the power of 7 over 2 divided by 7 over 2, which is the same as multiplying by 2 over 7, minus 2 times u to the power of 5 over 2 divided by 5 over 2, which is the same as multiplying by 2 over 5, plus u to the power of 3 over 2 divided by 3 over 2, which is multiplying by 2 over 3, plus c. So to simplify this, 2 times 2 over 5 is 4 over 5. So 1 over 2 times 2 over 7 is 1 over 7 u to the power of 7 over 2 minus 1 over 2 times 4 over 5, which is 2 over 5 u to the power of 5 over 2 plus 1 over 2 times 2 over 3, which is 1 over 3 u to the power of 3 over 2 plus c. And just a bit more. So we have 1 over 7 times x squared plus 1 to the power of 7 over 2 minus 2 over 5 times x squared plus 1 to the power of 5 over 2 plus 1 over 3 times x squared plus 1 to the power of 3 over 2 plus c. The integral of 1 over x squared plus 2 dx. So this one can be solved with U-substitution, and let me show you how. So the first thing I'm going to do is factor out a 2. Okay, so we have the integral of 1 over 2 times 1 over 2 x squared plus 1 dx, and you will see why I do this in a second. Then we can bring this 2 outside of the integral. So we have 1 over 2, the integral of 1 over x squared over 2 plus 1 dx. So looking at this, we have x squared over 2, right? We can turn this into x over the square root of 2 to the power of 2. And then we say let u equal to x over the square root of 2. So this is the trick to solving this integral. Now let's go ahead and do that. We have 1 over 2, the integral of 1 over x over the square root of 2 to the power of 2 plus 1 dx. Then let u equal to x over the square root of 2. Then differentiating it, we have du over dx, and that's equal to 1 over the square root of 2. So the square root of 2 times du is equal to dx. Now we put it back into this integral. So we have 1 over 2, the integral of 1 over u to the power of 2. So we replace this with a u, and we have u to the power of 2 plus 1, and dx is the square root of 2 times du. So we have the square root of 2 times du. And because this is a constant, we can bring it outside of the integral. So we're going to bring it outside, and we're going to put it at the numerator like this. And the next step is to find the antiderivative of 1 over u squared plus 1, and it's not very difficult. Now, if you look at this formula sheet, you can see that the derivative of arctan of x is 1 over x squared plus 1. Now, we have the integral of 1 over u squared plus 1 du. So it's very similar to this, and you know that the antiderivative is going to be arctan of u plus c. We have the square root of 2 over 2 times arctan of u plus c. And we also have to turn the u back into the x. We have the square root of 2 over 2 times arctan of x over the square root of 2 plus c. So whenever you get an integral in the form of 1 over x squared plus a dx, you can always use this formula. And so this will be equal to 1 over the square root of a times arctan of x over the square root of a plus c. The integral of x to the power of 3 over x squared plus 5 to the power of 2 dx. Let u equal to x squared plus 5, then du over dx is equal to 2x. So du is equal to 2x dx, and dx is equal to 1 over 2x du. Now let's go ahead and change this to u form. We get x to the power of 3 over u to the power of 2, and dx is 1 over 2x du. We can cancel this out with this, and we get a 2 up here. We can also move this 2 outside of the integral. So we get 1 over 2 times the integral of x to the power of 2 over u to the power of 2 du. At this point, what is x to the power of 2? It is very simple. We know that u is equal to x squared plus 5, so x squared will be u minus 5. We get 1 over 2 times the integral of u minus 5 over u squared du. This is the same thing as 1 over 2 times the integral of u over u squared minus 5 over u squared du. Continuing on, we have 1 over 2 times the integral of 1 over u minus 5 over u to the power of 2 du. And then we split this integral apart. We get 1 over 2 times the integral of 1 over u du minus the integral of 5 over u squared du. So that's what I mean when I say split the integral apart. And you can also bring this 5 in front. We get 1 over 2 times, what is the antiderivative of 1 over u du? Well, it's going to be the ln of the absolute value of u, then minus 5. First of all, I'm going to rewrite this as u to the power of negative 2. So that way, it's easier to find the antiderivative. So the antiderivative of this is what? It's going to be u to the power of negative 1 over negative 1 plus c. So this is times negative 1 over u plus c. We get 1 over 2 times the ln of the absolute value of u minus 5 times the negative 1 over u. This is the same as plus 5 over u plus c. And we're almost done. So we get 1 over 2 times ln of u, and we have to change the u back to the x. So we get the ln of x squared plus 5 plus 5 over x squared plus 5 plus c. And one thing I want to mention is that x squared plus 5, that function is always above the horizontal axis. And because of this, you can get rid of the absolute value. Then we have 1 over 2 times ln of x squared plus 5 plus 1 over 2 times 5. That gives us 5 over 2 times 1 over x squared plus 5 plus 1 over 2 times c. Okay, but since c is just a constant, you don't need to write 1 over 2 times c. We can just write it as c. So that's it. This here is the answer to that integral. The integral of x squared over x plus 1 to the power of 3 dx. The first will say let u equal to x plus 1, then du over dx is 1 because we differentiate it, then du is equal to dx. Let's substitute the x into the u. So we have at the numerator x squared over x plus 1 becomes u. So we have u to the power of 3, and dx is simply du. So what is x squared? Well, if you look at this here, you can see that u is equal to x plus 1. So x is equal to u minus 1, and x squared is u minus 1 to the power of 2. And u minus 1 to the power of 2 is what? It's going to be u squared minus 2u plus 1. So here x squared is basically u squared minus 2u plus 1. This becomes u to the power of 2 over u to the power of 3 minus 2u over u to the power of 3 plus 1 over u to the power of 3d. Then we simplify it. So u squared over u to the power of 3 is 1 over u minus 2u over u to the power of 3 is 2 over u squared plus 1 over u to the power of 3d. Then we're going to split the integral apart. So we have the integral of 1 over u du minus 2 times the integral of 1 over u squared du plus the integral of 1 over u to the power of 3 du. Now, instead of writing 1 over u to the power of 2, I'm going to write it as u to the power of negative 2. And same thing over here. This becomes u to the power of negative 3. it's time to find the antiderivative. So what is the antiderivative of 1 over u du? Well, it's going to be the ln of absolute value of u minus 2 times the antiderivative of u to the power of negative 2. Well, let's see. We have u to the power of negative 1 over negative 1 plus the antiderivative of u to the power of negative 3. That's going to be u to the power of negative 2 over negative 2 plus c. Then what will this give us? Well, it will give us the ln of absolute value of u minus 2 times, this is going to be negative 1 over u, plus this would be negative 1 over 2 times 1 over u to the power of 2 plus c. This is the ln of absolute value of u plus 2 over u. Then here we have minus 1 over 2 times u to the power of 2 plus c. And the final step is to substitute the u with the x. So here we have the ln of absolute value of x plus 1 plus 2 over x plus 1 minus 1 over 2 times x plus 1 to the power of 2 plus c. The integral of x to the power of 3 times cosine of x to the power of 4 plus 2 dx. So first of all, let u equal to x to the power of 4 plus 2. Then we differentiate it. So du over dx, what's that going to be? Well, that's going to be 4 times x to the power of 3. So du is going to be 4x to the power of 3 dx. dx is 1 over 4x to the power of 3 du. Now let's go ahead and substitute it back into this integral. We have x to the power of 3 times cosine of x to the power of 4 plus 2. And that's going to be u. And dx is 1 over 4x to the power of 3 du. And as you can see, the x to the power of 3's will cancel out. We can also move the 4 outside of the integral because it's only a constant. So we have 1 over 4 times cosine of u du. And what is the antiderivative of cosine of u? Well, it's going to be sine of u plus c, right? So we have 1 over 4 times sine of u plus c. And the last step is to substitute the u back with the x. So we have 1 over 4 times sine of x to the power of 4 plus 2. Then finally, plus c. The integral of x over the square root of 1 minus 4x squared dx. So this can be solved with u substitution and let u equal to 1 minus 4x to the power of 2. And we differentiate it, so du over dx is equal to negative 4 times 2 times x. That's going to be negative 8x. So du is equal to negative 8x dx. Then finally dx is negative 1 over 8x u. We have the integral of x over the square root of u. Then dx is negative 1 over 8x du. So times negative 1 over 8x du. And as you can see, the x will cancel out. As well, you can move the 1 over 8 with the negative sign outside of the integral because it's only a constant. So we have negative 1 over 8 times the integral of 1 over the square root of u du. We can also rewrite this as negative 1 over 8 times the integral of u to the power of negative 1 over 2 du. And we need to find the antiderivative of u to the power of negative 1 over 2. So here we have negative 1 over 8 times the antiderivative of this, which is u to the power of positive 1 over 2 over 1 over 2 plus c. This is the same as negative 1 over 8 times 2 times the square root of u plus c. So this is negative 1 over 4 times the square root of u plus c. And we put the u back with the x. So we have negative 1 over 4 times the square root of 1 minus 4x to the power of 2 plus c. The integral of tan of x dx. So this can be solved with u substitution. The first step is to convert this into sine of x over cosine of x, because tan of x is equal to sine of x over cosine of x. Then the second step is to let u equal to cosine of x. And the reason why I do this is because I want to cancel out the sine of x, which you will see. So du over dx, we differentiate it. This will give us a negative sine of x So du is equal to negative sine of x dx, and dx is 1 over negative sine of x du. We're going to plug it into the integral, so we have sine of x over cosine of x, which is u. We have u, and then dx is 1 over negative sine of x du. So times 1 over negative sine of x du. And as you can see, the sine of x will cancel out, and we also have to move this negative sign outside of the integral. So we have negative the integral of 1 over u du. The antiderivative of 1 over u is what? It's going to be the ln of absolute value of u plus c, and this will give us negative ln of the absolute value of u, which we will change back to cosine of x. So cosine of x plus c. The integral of sine of x times cosine of x dx. So go ahead and pause this video and give this one a try, and then we'll go over the answer together. Are you ready? Well, the first thing I'm going to do is to let u equal to cosine of x. Then we differentiate it. So du over dx is equal to negative sine of x. So du is equal to negative sine of x dx. And dx is negative 1 over sine of x du. So we put it into this integral. We have sine of x times cosine of x, which we already let it to be u. Then dx is going to be negative 1 over sine of x du. So times negative 1 over sine of x du. So the signs here will cancel out. We also have to move the negative sign outside of the integral. So we have negative integral of u du. And what is the antiderivative of u? Well, it's going to be u to the power of 2 over 2 plus c. So this will give us negative 1 over 2 times u to the power of 2 plus c, and the final step is to substitute cosine of x back into the u. So we have negative 1 over 2 times cosine of x to the power of 2 plus c. The integral of sine to the power of 2 of x times cosine of x dx. So here, this just means sine of x times sine of x, and we write it with the 2 at the top. The first thing I'm going to do is to let u equal to sine of x. And you will see that this allows us to cancel out the cosine of x. So we differentiate it first, so we get du over dx, and the derivative of sine of x is positive cosine of x. So du is cosine of x dx, and dx is 1 over cosine of x times du. So we're going to substitute the u into this, and we get u to the power of 2 times cosine of x times dx, and dx is 1 over cosine of x du. So times 1 over cosine of x times du. So as you can see, the cosine of x will cancel out, and that leaves us with the integral of u to the power of 2 du. So the antiderivative of this will be what? It will be 1 over 3 times u to the power of 3 plus c, and we change the u back into sine of x. So 1 over 3 times sine of x to the power of 3 plus c. The integral of sine of x times sine of cosine of x dx. So this basically means that instead of writing sine of x, we just replace the x with cosine of x. So that's basically what this means right here. So the first step is to let u equal to cosine of x. And this will allow us to get rid of this sign, as you will see. So du over dx is going to be the derivative of cosine of x, which is negative sine of x. So du is equal to negative sine of x times dx, and dx is equal to negative 1 over sine of x times du. So we have the integral of sine of x times sine, and instead of writing cosine of x, we are going to write u. So sine of u, and dx is simply negative 1 over sine of x times du. As you can see, the sine of x will cancel out. We have the integral of sine of u times du, and don't forget this negative sign. We're going to write it at the front. So the antiderivative of sine of u is what? It's going to be negative cosine of u plus c. So this will give us positive cosine of u plus c. And the final step is to substitute cosine of x back into the u, which gives us cosine of x. plus c. The integral of cosine of the square root of t over the square root of t dt. Now, the beautiful thing about U-substitution is it allows us to simplify things. So we can simplify the square root of t into a u. So let u equal to the square root of t, which is basically e to the power of 1 over 2. Then we differentiate it, so du over dt. That's going to be 1 over 2 times t to the power of negative 1 over 2. That's basically 1 over 2 square root of t. So this means 2 times the square root of t du is going to be equal to dt. Let's go ahead and substitute it back into this integral. So we have the integral of cosine of u over the square root of t, which is also u. And how about this dt here? Well, dt is 2 times the square root of t times du. So 2 times the square root of t times du. And notice that we also have another square root of t here, which we can turn it into a u. So what we're going to do here is cancel out this u with this u, and we end up with the integral of cosine of u. And we're going to move this 2 outside of the integral because it is a constant, and then we have the du. The antiderivative of cosine of u, and it will be sine of u plus c. So we have 2 times sine of u plus c, which gives us 2 times sine of the square root of t. So sine of the square root of t plus c. The integral of e to the power of x plus e to the power of x. So in order to solve this, we need to simplify this first. And there's a rule that says if we have e to the power of a plus b, then this is the same as e to the power of a times e to the power of b. So let's go ahead and do that. This will be equal to the integral of e to the power of x times e to the power of x dx. And this is where we use U-substitution in order to simplify this. So let u equal to e to the power of x. Then we differentiate it. So du over dx, and the derivative of e to the power of x is also e to the power of x. So we end up with du is equal to e to the power of x dx, and dx is going to be 1 over e to the power of x du. So here we have the integral of e to the power of x, right? And that's basically a u times e to the power of e to the power of x. So this right here will be a u, and the dx is 1 over e to the power of x du. So times 1 over e to the power of x du. And notice that this e to the power of x is also a u. So let's change that. We have here a u. And you might notice that we can cancel out this u and this one. So here we have the integral of e to the power of u du. Now, what is the antiderivative of e to the power of u? It's going to be e to the power of u plus c. And the final step is to substitute the u back to our original x variable. So here we have e to the power of x plus c. The integral of e to the power of x over e to the power of 2x plus 2 times e to the power of x plus 1 dx. So first of all, you might notice that this right here is the same as e to the power of x plus 1 to the power of 2. Now you can try to expand this and you will get this. Okay, so this is equal to the integral of e to the power of x over this right here and dx. And then the next step is to simplify this and say let u equal to e to the power of x plus 1. So du over dx is equal to e to the power of x. So du is e to the power of x dx, and dx is 1 over e to the power of x du. We're going to have the integral of e to the power of x over u to the power of 2. And how about our dx? Well, dx is 1 over e to the power of x du. So times 1 over e to the power of x du. Here, the e to the power of x will cancel out. We have the integral of 1 over u to the power of 2 du. That's basically the same as the integral of u to the power of negative 2 du. So the antiderivative of this is u to the power of negative 1 over negative 1 plus c, which is negative 1 over u plus c. And we substitute e to the power of x plus 1 back into our expression, giving us negative 1 over e to the power of x plus 1 and plus c. the integral of cotangent of x times the ln of sine of x dx. So the first thing we want to do here is notice that cotangent of x is the same as 1 over tan of x. And this is the same as 1 over sine of x over cosine of x, because tangent of x is sine of x over cosine of x. And this will be simply cosine of x over sine of x. So that's the first step to simplifying this integral. We have the integral of cosine of x over sine of x times the ln of sine of x dx. We can also simplify this further by turning the sine of x into a u. So let u equal to sine of x. This means that when we differentiate it, du over dx, that's going to give us cosine of x. So du is cosine of x times dx, and dx is going to be 1 over cosine of x times du. So what is our dx going to be? Well, dx is 1 over cosine of x du, so we're going to substitute that in. So this cosine will cancel out with this cosine, and we also want to turn the sine of x into a u as well. We will end up with the integral of the ln of u over u times du. You might recognize this integral from our previous examples. So in order to solve this, you have to use u-substitution again. So let v equal to the ln of u. So differentiating it with dv over du, that's going to be 1 over u. So u times dv is equal to du. So over here, we're going to have the integral of v over u, and du is going to be u times dv. So this is going to be u times dv. And now as you can see, the u's will cancel out, and we have the integral of v dv. So the antiderivative of this is simply 1 over 2 v to the power of 2 plus c. We change the v back to the u, which gives us 1 over 2, and v is basically ln of u, right? So we have ln of u to the power of 2 plus c. And now we change the u back to our sine of x. We will have 1 over 2 times the ln of sine of x to the power of 2 plus c. So that's basically it for today. I hope you guys enjoyed this video. I hope you liked it. If you did, don't forget to hit subscribe. And in the next video, we will go over integration by parts.